Okay, we're going to look at part C, the parachute drop. And the important thing to notice is this picture over here and understand what's happening here. So I'm going to zoom in. When the package first is dropped for the helicopter, from here to here, the parachute is not open. So here, it's just falling in free fall. That is this formula right here. Right there. Where the distance is just related to gravity and time. And it tells us that that is the distance when the package is in free fall. So here it's just the 1/2 GT squared. Then here the parachute opens. This part is what they call the deployed height. It's where the parachute is open on it. And you'll notice that they have deployment height, velocity and time, v equals v over t. And then we can do the same thing to figure out the velocity versus the distance in the free fall part. Then the time and the height, if I add these two times together, I get the whole time. If I add these two heights together, I get the whole height. Notice again, you have to use this for G. If you use something else, you're going to get the answers wrong. And then this worksheet does a really good job of saying, what if you need to find the free fall time? What if this is missing? What if you need to find the free fall distance? What if this is missing? This is only missing, and if you look through all these examples, it has all these examples except it's missing one thing, and I'm going to show you how to do that one right now. What if we have this problem right here? Here, they gave me these three, and I'm missing these over here. Well, this is the free fall formula we just looked at. But this time, I don't know the time, but I do know the distance. So I don't know the distance here. I know gravity is 9.81. And I don't know the time. So how do we solve this kind of problem? Well, I'm going to plug in the free fall distance right here. And I want to find the free fall time right here. This is an algebra problem. So first I need to multiply those together. Notice that I'm not rounding this off. If you round these off in between, you're going to get these wrong. Then how do I solve this? Well, I divide both sides. And I get 36 equals t squared. Now, how do I finish solving this? That's right, when I've got it squared, I take the square root. And I get 6 seconds. Now I know the free fall time is 6. And now I can do the other parts there. The height of the helicopter is easy because we know the free fall distance right there. And we know the deployment height right here. So to get the total height, we just add those together, and I got it right here. This is 234.73. Now I'm still looking for the total time. Now we need to find the total time. If we look at the papers here, it tells us the total time is the free fall time plus the deployment time. But if I look at what I know, I only know the free fall time. I don't know the deploy time over here. There's no deploy time on here. So what I need to do is figure out the deploy time first. Well, what we know is the deployment height is equal to the velocity times the time. So I have the distance equals velocity times time. And what I want to find is the time. So if I divide both sides by v, I get time equals distance divided by velocity. Here's my distance. Here's my velocity. Plug that in my calculator. And I get the time is 11.63 seconds. That's the deploy time. Add that onto the free fall time, and we get the total time is 17.64. That's it.